result is not undefined. Throw a type error exception. 1. Else a return if abrupt. Result 2. Let this binding be constructor env get this binding. 3. Assert this binding is an
Chatbot is not AI.
3. Ordinary function create. Record or null, and returns an ECMA script function object. It is used to specify the runtime creation of a new function with a default internal method and no internal method, although one may be Dart source text is the source text of the syntactic definition of the function to be.
So I need to find.
Steps when called.
They got a freaking
slots listed in table.
splinter on my wrist. What the hell?
8. Function prototype. Internal slots list. Set F to the definition specified.
This mousepad sucks.
1. Set F to source text. Set F to parameter list. Set F to body. If the source text matched body is strict mode code, let strict be true, else let strict be false. Set F to strict. If this mode is lexical, this. Set F to lexical 0. Else if strict is true, set F to strict 1.
So basically,
Set F to
all I need to do is get an image on a quad.
set F to private env.
Apparently it's like 200 plus lines of code.
Set F to the current realm record 7. Set F to undefined 8. Set F to a new empty list 9. Set F to a new empty list 0. Set F to.
It says, attaching an image texture to a quad in Vulkan typically takes around 200 to 350 lines of code.
National 2020.
Holy shit.
9. 1 0.
No wonder it's not working.
4.
Chatbot can't output up to 200 lines of code without errors.
E.
And resolving those errors
R. I.
isn't going to make it work because a bunch of shit was missing in the first place.
F. U. C. T. I. O. N. Capital P. R. O. P. E. R. T. I.
So I'm like, through this not get done.
The
This
abstract.
is so dumb.
Capital A. D.
And Chatbot's not AI. It's ridiculous.
S. T. R. I. C. T.
If you're like investing money into AI, I would stop. Because you're a fucking idiot.
I. O. N. Capital P. R. O. P. E. R. T. I. E. Takes arguments F, a function object, and realm, a realm record, and returns unused. It performs the following steps when called. Assert. Realm exists and has been initialized. Let thrower be realm. Perform. Define property or throw. F. Caller. Property descriptor. Thrower. Enumerable. False. True. Perform. Define property or throw. F. Arguments. Property descriptor. Thrower. Enumerable. False. True. Return unused. 0, 2, 4, 1% throw type error percent. This function is the percent throw type error percent intrinsic object. It is an anonymous built-in function object that is defined once for each realm. It performs the following steps when called. Throw type error exception. The value of the internal slot of this function is false. The length property of this function has the attributes false, false, false. The name property of this function has the attributes false, false, false. 0, 2, 5. Make constructor. F. Writable prototype. Prototype. The abstract operation make constructor takes argument F, an ECMA script function object or a built-in function object, and optional arguments writable prototype, a boolean, and prototype, an object, and returns unused. It converts f into a constructor. It performs the following steps when called. If f is an ECMA script function object, then a assert is constructor, f is false, b assert. F is an extensible object that does not have a prototype own property. C set f to the definition specified in 1, 0, 2, 2. Else a set f to the definition specified in 1, 0, 3, 2. Set f to base. If writable prototype is not present, set writable prototype to true. If prototype is not present, then a set prototype to ordinary object create. %object prototype %b perform. Define property or throw prototype constructor property descriptor f writable prototype false true perform. Define property or throw f prototype property descriptor prototype writable prototype false return unused. 80 ECMA International 2024 102 6 Make class constructor f. The abstract operation make class constructor takes argument f, an ECMA script function object, and returns unused. It performs the following steps when called. Assert f is false, set f to true, return unused. 0, 2, 7 Make method f home object. The abstract operation make met hard takes arguments f, an ECMA script function object, and home object, an object, and returns unused. It configures f as a method. It performs the following steps when called. Set f to home object, return unused. 0, 2, 8 Define method property, home object, key, closure, enumerable. The abstract operation define method property takes arguments home object, an object, key, a property key or private name, closure, a function object, and enumerable, a boolean, and returns either a nor.
Fucking kidding me.
The following steps when called. Assert home object is an ordinary extensible object. If key is a private name, then
This is where chatbot is getting its info from.
desc be the property descriptor.
ISB.
Enumerable, true, b perform. Define property or throw home object.
Is
Note, define property or throw only returns an abrupt completion when attempting to define a
fucking shit.
prototype. D return unused. 0, 2, 9 Set function name f name prefix. The abstract operation set function name takes arguments f, a function object, a name, a property key or private name, and optional argument prefix, a string, and returns unused. It adds a name property to f. It performs the following steps when called. Assert f is an extensible object that does not have a name own property. If name is a symbol, then a let description the name's value. B if description is undefined. Set name to the empty string. C else. Set name to the string concatenation of description. And else if name is a private name, then a set name to name. If f has an internal slot, then a set f to name. If prefix is present, then a set name to the string concatenation of prefix. The code unit 0 times 0020 space and name. B if f has an internal slot, then I optionally set f to name. Perform. Define property or throw f name property descriptor name false enumerable false true return unused. ECMA International 2024 181 the 10th of February 2010 Set function length f length. The abstract operation set function length takes arguments f, a function object, and length, a non-negative int, 0 plus, and returns unused. It adds a length property to f. It performs the following steps when called. Assert f is an extensible object that does not have a length own property. Perform. Define property or throw f length property descriptor length false enumerable false true return unused. 0, 2, 1, 1 capital F U N C T I O N capital D E C L T I O N capital I N S T A N T I A T I func arguments list. The abstract operation view function declaration instantiation takes arguments func, an ECMA script function object, and arguments list, a list of ECMA script language values, and returns either a normal completion containing unused or an abrupt completion. Func is the function object for which the execution context is being established. Note 1. When an execution context is established for evaluating an ECMA script function, a new function environment record is created and bindings for each formal parameter are instantiated in that environment record. Each declaration in the function body is also instantiated. If the function's formal parameters do not include any default value initializers, then the body declarations are instantiated in the same environment record as the parameters. If default value parameter initializers exist, a second environment record is created for the body declarations. Formal parameters and functions are initialized as part of capital F U N C T I O N capital D E C L A R A T I O N capital I N S T A N T I A T I. All other bindings are initialized during evaluation of the function body. It performs the following steps when called. Let callee context be the running execution context. Let code be func. Let strict be func. Let formals be func. Let parameter names be the bound names of formals. If parameter names has any duplicate entries, let has duplicates be true. Otherwise, let has duplicates be false. Let simple parameter list be a simple parameter list of formals. Let has parameter expressions be contains expression of formals. Let var names be the var declared names of code. 0. Let var declarations be the var scope declarations of code. 1. Let lexical names be the lexically declared names of code. 2. Let function names be a new empty list. 3. Let functions to initialize be a new empty list. 4. For each element D of var declarations, in reverse list order, do if D is neither a variable declaration nor a binding nor a binding identifier. Then, I assert, D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration. 2. Let fn be the sole element of the bound names of D. 3. If function names does not contain fn, then insert fn as the first element of function names. Note, if there are multiple function declarations for the same name, the last declaration is used. Insert D as the first element of functions to initialize. 5. Let arguments object needed be true. 6. If func is lexical, then a note, arrow functions never have an arguments object. B set arguments object needed to false. 7. Else if parameter names contains arguments, then a set arguments object needed to false. 82. ECMA International 2024. 18. Else if his parameter expressions is false, then if function names contains arguments or lexical names contains arguments, then I set arguments object needed to false. 9. If strict is true or has parameter expressions is false. THN, a note, only a single environment record is needed for the parameters, since calls to eval in strict mode code cannot create new bindings which are visible outside of the eval. B let env be the lexical environment of callee context. 0. Else, a note, a separate environment record is needed to ensure that bindings created by direct eval calls in the formal parameter list are outside the environment where parameters are declared. B let callee env be the lexical environment of callee context. C let env be new declarative environment. Callee env. B assert, the variable environment of callee context is callee env. E set the lexical environment of callee context to env. 1. For each string param name of parameter names, do a let already declared env has binding. Param name. B note, early errors ensure that duplicate parameter names can only occur in non-strict functions that do not have parameter default values or rest parameters. See if already declared is false. Then I perform env create mutable binding, param name, false 2. If his duplicates is true, then perform env initialize binding, param name, undefined 22. If arguments object needed is true, then if strict is true or simple parameter list is false, then I let AOB create a mapped arguments object, arguments list. B else, I note, a mapped argument object is only provided for non-strict functions that don't have a rest parameter. Any parameter default value initial.
Maybe check back into this.
2. Let it
I don't want the C++. I don't want to convert it.
list env
Chatbot sucks though. I'm tired of wasting time. Just one more try. Come on, Chatbot. You can do it.
binding. So it
I believe in you, Chatbot. Do this for me. I don't give a fuck. Just do the GPU stuff. Just do it.
lies binding.
Do it, Chatbot. Do it.
F let parameter bindings be
So stupid.
parameter names and arguments. 3. Else a let parameter bindings be parameter names. 4. Let iterator record be create list iterator record. Arguments list. 5. If his duplicates is true, then a perform iterator binding initialization of formals with arguments iterator record and undefined 26. Else a perform iterator binding initialization of formals with arguments iterator record and env27. If his parameter expressions is false, then a note, only a single environment record is needed for the parameters in top-level vars. Be let instantiated var names be a copy of the list parameter bindings. See for each element n of var names. Do if instantiated var names does not contain n, then append n to instantiated var names. Perform env create mutable binding. N false. Perform env initialize binding. N undefined.
Oh my god, here it goes again.
8. Else a note. A separate environment record is needed to ensure that closures created by expressions in the formal parameter list do not have visibility of declarations in the function body. B let var env be new declarative environment. Env C set the variable environment of callee context to var env. D let instantiated var names be a new empty list. E for each element n of var names.
We didn't do anything.
Instantiated var names does not contain n. Then, ECMA International 2024 183 1. Append n to instantiated var names. Perform var env create mutable binding. N false. If parameter bindings does not contain n, or if function names contains n, then a let initial value be undefined 4. Else, a let initial value be env get binding value. N false. Perform var env initialize binding. N initial value. Note. A var with the same name as a formal parameter initially has the same value as the corresponding initialized parameter. 9. Note. An xb 3 2 1 adds additional steps at this point. 0. If strict is false, then a let lexenv be new declarative environment. Var env be note. Non-strict functions use a separate environment record for top-level lexical declarations so that a direct eval can determine whether any var scope declarations introduced by the eval code conflict with pre-existing top-level lexically scoped declarations. This is not needed for strict functions because a strict direct eval always places all declarations into a new environment record. 1. Else, a let lexenv be var env. 2. Set the lexical environment of callee context to lexenv. 3. Let lex declarations be the lexically scoped declarations of code. 4. For each element d of lex declarations, do a note. A lexically declared name cannot be the same as a function-generator declaration, formal parameter, or a var name. Lexically declared names are only instantiated here but not initialized. B for each element dn of the bound names of d. Do if this constant declaration of d is true, then perform lexenv create immutable binding. Dn true 2. Else perform lexenv create mutable binding. Dn false 5. Let private env be the private environment of callee context. 6. For each parse node f of functions to initialize, do a let fn be the sole element of the bound names of f. B. Let fo be instantiate function object of f with arguments lex env and private env. C. Perform var env set mutable binding fn fo false. 7. Return unused. 0.3 Built-in function objects. A built-in function object is an ordinary object. It must satisfy the requirements for ordinary objects set out in 10.1. In addition to the internal slots required of every ordinary object, see 10.1. A built-in function object must also have the following internal slots: a realm record that represents the realm in which the function was created, a string that is the initial name of the function. It is used by 2, 0, 2, 3, 5. The initial value of a built-in function object's internal slot is %function prototype %, unless otherwise specified. A built-in function object must have an internal method that conforms to the definition in 1.0.3.1. A built-in function object has an internal method if and only if it is described as a constructor, or some algorithm in this specification explicitly sets its internal method. Such an internal method must conform to the definition in 1.0.3.2. An implementation may provide additional built-in function objects that are not defined in this specification. Note 2b. 3.2 provides an extension to the above algorithm that is necessary for backwards compatibility with web browser implementations of ECMAScript that predate ECMAScript 2015. 84. Copyright sign, ECMA International 2024, 1.0.3.1. This arguments list. The internal method of a built-in function object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called.
Oh my god.
Or construct f. This arguments list, undefined 1.0.3.2. Arguments list, new target. The internal method of a built-in function object f, when the method is present, takes arguments list, a list of ECMAScript language values, and new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Return, built-in call or construct, f, uninitialized, arguments list, new target 1.0.3.3 built-in call or construct, f. This arguments list, new target. The abstract operation built-in call or construct takes arguments f, a built-in function object. This argument, an ECMAScript language value or uninitialized, arguments list, a list of ECMAScript language values, and new target, a constructor or undefined, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let caller context be the running execution context. If caller context is not already suspended, suspend caller context. Let callee context be a new execution context. Set the function of callee context to f. Let callee realm be f. Set the realm of callee context to callee realm. Set the script or module of callee context to null. Perform any necessary implementation-defined initialization of callee context. Push callee context onto the execution context stack. Callee context is now the running execution context. 0. Let result be the completion record that is the result of evaluating f in a manner that conforms to the specification of f if this argument is uninitialized. This value is uninitialized. Otherwise, this argument provides this value arguments list provides the named parameters new target provides the new target value. 1. Note, if f is defined in this document, the specification of f is the behavior specified for it via algorithm steps or other means. 2. Remove callee context from the execution context stack and restore caller context as the running execution context. 3. Return result. 0, 3, 4. Create built-in function, behavior, length, name, additional internal slots list, realm, prototype, prefix. The abstract operation create built-in function takes arguments behavior, an abstract closure, a set of algorithm steps, or some other definition of a function's behavior provided in this specification, length, a non-negative integer or plus, name, a property key or a private name, and additional internal slots list, a list of names of internal slots, and optional arguments realm, a realm record, prototype, an object or null, and prefix, a string. And returns a function object. Additional internal slots list contains the names of additional internal slots that must. Note: when callee context is removed from the execution context stack, it must not be destroyed if it has been suspended and retained by an accessible generator for later resumption. ECMA International 2024-185 be defined as part of the object. This operation creates a built-in function object. It performs the following steps when called. If realm is not present, set realm to the let internal slots list be a list containing the names of all the internal slots that 10.3 requires for the built-in function object that is about to be created. Append to internal slots list the elements of additional internal slots list. Let func be a new built-in function object that, when called, performs the action described by behavior, using the provided arguments as the values of the corresponding parameters specified by behavior. The new function object has internal slots whose names are the elements of internal slots list, and an internal slot. Set func to prototype, set func to true, set func to realm, set func to null, 0. Perform set function length, func, length, 1. If prefix is not present, then a perform set function name, func, name 12. Else, a perform set function name, func, name, prefix 13. Return func. Each built-in function defined in this specification is created by calling the create built-in function abstract operation. 0.4 Built-in exotic object internal methods and slots. This specification defines several kinds of built-in exotic objects. These objects generally behave similar to ordinary objects except for a few specific situations. The following exotic objects use the ordinary object internal methods except where it is explicitly specified otherwise below. 0, 4, 1 Bound function exotic objects. A bound function exotic object is an exotic object that wraps another function object. A bound function exotic object is callable. It has an internal method and may have an internal method. Calling a bound function exotic object generally results in a call of its wrapped function. An object is a bound function exotic object if its and, if applicable, internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in bound function create. Bound function exotic objects do not have the internal slots of ECMA script function objects listed in Table 30. Instead, they have the internal slots listed in Table 31, in addition to Table 31, internal slots of bound function exotic objects. Internal slot. Type. Description. Bound target function. A callable object. The wrapped function object. Bound this. An ECMA script language value. The value that is always passed as this value when calling the wrapped function. Bound arguments. A list of ECMA script language values. A list of values whose elements are used as the first arguments to any call to the wrapped function. 186. ECMA International 2024 10411. This arguments list. The internal method of a bound function exotic object F takes arguments this argument, an ECMA script language value, and arguments list, a list of ECMA script language values, and returns either a normal completion containing an ECMA script language value or a throw completion. It performs the following steps when called. Let target be F, let bound this be F, let bound args be F, let args be the list concatenation of bound args and arguments list. Return. Call. Target. Bound this. Args 0, 4, 1, 2. Arguments list. New target. The internal method of a bound function exotic object F takes arguments list, a list of ECMA script language values, and new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let target be F, assert, is constructor, target, is true. Let bound args be F. Let args be the list concatenation of bound args and arguments list. If same value, F. new target is true. Set new target to target. Return. Construct target args new target 0 4 1 3 bound function create target function bound this bound args. The abstract operation bound function create takes arguments target function, a function object, bound this, an ECMA script language value, and bound args, a list of ECMA script language values, and returns either a normal completion containing a function object or a throw completion. It is used to specify the creation of new bound function exotic objects. It performs the following steps when called. Let proto be target function. Let internal slots list be the list concatenation of E and the internal slots listed in table 31. Let obj be make basic object. Internal slots list. Set obj to proto. Set obj as described in 1 0 4 1 1. If this constructor target function is true, then a set obj as described in 1 0 4 1 2. Set obj to target function. Set obj to bound this. Set obj to bound args 0. Return obj 0 4 to array exotic objects. An array is an exotic object that gives special treatment to array index property keys C6 1 7. A property whose property name is an array index is also called an element. Every array has a non-configurable length property whose value is always a non-negative integral number whose mathematical value is strictly less than 32. The value of the length property is numerically greater than the name of every known property whose name is an array index, whenever a known property of an array is created or changed. Other properties are adjusted as necessary to maintain this invariant. Specifically, whenever a known property is added whose name is an array index, the value of the length property is changed, if necessary, to be one more than the numeric value of that array index. And whenever the value of the length property is changed, every own property whose name is an array index whose value is not smaller than the new length is deleted. This constraint applies only to own. ECMA International 2024 187. Properties of an array and is unaffected by length or array index properties that may be inherited from its prototypes. An object is an array exotic object, or simply, an array, if its internal method uses the following implementation, and its other essential internal methods use the definitions found in 10.1. These methods are installed in array create 0, 4, 2, 1, p, desc. The internal method of an array exotic object takes argument p, a property key, and desc, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is length, then a return array set length a desc. Else if p is an array index, then a let length desc be ordinary get own property a length b assert is data descriptor length desc is true c assert length desc is false d let length be length desc e assert length is a non-negative integral number f let index b 32 p g if index length and length desc is false return false h let succeeded b ordinary define known property a p desc I have succeeded is false return false j if index length then I set length desc index plus 1 2 set succeeded to ordinary define known property a length desc 3 assert succeeded is true k return true return ordinary define now end property a p desc 0 4 2 to array create length proto. The abstract operation array create takes argument length, a non-negative integer, and optional argument proto an object, and returns either a normal completion containing an array exotic object or a throw completion. It is used to specify the creation of new arrays. It performs the following steps when called. If length 232 1, throw a range error exception. If proto is not present, set proto to %array prototype %. Let a be make basic object. Set a to proto. Set a is specified in 1 0 4 2 1. Perform ordinary define known property a length property descriptor length true false false. Return A, 0, 4, 2, 3. Array species create. Original array, length. The abstract operation array species create takes arguments original array, an object, and length, a non-negative integer, and returns either a normal completion containing an object or a throw completion. It is used to specify the creation of a new array or similar object using a constructor function that is derived from original array. It does not enforce that the constructor function returns an array. It performs the following steps when called. Let is array be is array, original array. If is array is false, return array create, length. Let C be get, original array, constructor. If this constructor, C, is true, then 88. ECMA International 2024. A let this realm be the current realm record. B let realm be. Get function realm. C. See if this realm and realm are not the same realm record. Then, I have same value. C. Realm is true. Set C to undefined. If C is an object, then I set C to get. C. Add at species. B. If C is null, set C to undefined. If C is undefined, return array create, length. If this constructor, C, is false, throw a type error exception. Return construct, C, length, 0, 4, 2, 4. Array set length, A, desk. The abstract operation array set length takes arguments A, an array, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If desk does not have a field, then a return ordinary define known property A, length, desk. Let new len desk be a copy of desk. Let new len be 32 desk. Let number len be to number desk. If same value 0, new len number len is false. Throw a range error exception. Set new len desk to new len. Let old len desk be ordinary get own property A, length. Assert is data descriptor. Old len desk is true. Assert old len desk is false. 0. Let old len be old len desk. 1. If new len old len, then a return ordinary define known property A, length, new len desk. 2. If old len esc is false, return false. 3. If new len desk does not have a field or new len desk is true, then a let new writable be true. 4. Else, a note, setting the attribute to false is deferred in case any elements cannot be deleted. B let new writable be false. C set new len desk to true. 5. Let succeeded be ordinary define known property A, length, new len desk. 6. If succeeded is false, return false. 7. For each own property keep P of a such that P is an array indexant. 32. P, new len, in descending numeric index order. Do a let delete succeeded B. A, P, B. If delete succeeded is false, then I set new len desk to 32. P plus 1, 2. If new writable is false, set new len desk to false. 3. Perform ordinary define known property A, length, new len desk. 5. Return false. 8. If new writable is false, then assert succeeded to ordinary define known property A, length, property descriptor, false. B assert succeeded is true. 9. Return true. Note if original array was created using the standard built-in array constructor for a realm that is not the realm of the running execution context, then a new array is created using the realm of the running execution context. This maintains compatibility with web browsers that have historically had that behavior for the array prototype methods that now are defined using array species create. ECMA International 2024 189. Note, in steps 3 and 4, if desk is an object then its value of method is called twice. This is legacy behavior that was specified with this effect starting with the second edition of this specification. 0, 4, 3 string exotic objects. A string object is an exotic object that encapsulates a string value and exposes virtual integer index data properties corresponding to the individual code unit elements of the string value. String exotic objects always have a data property named length whose value is the length of the encapsulated string value. Both the code unit data properties and the length property are non-writable and non-configurable. An object is a string exotic object, or simply a string object, if its and internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in string create. String exotic objects have the same internal slots as ordinary objects. They also have an internal slot 1, 0, 4, 3, 1, p. The internal method of a string exotic object S takes argument p, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desk be ordinary get own property S, p. If desk is not undefined, return desk. Return string get own property S, p. 0, 4, 3, 2, p. Desk. The internal method of a string exotic object S takes arguments p, a property key, and desk, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let string desk be string get own property S, p. If string desk is not undefined, then a let extensible be S, p. Return is compatible property descriptor, extensible, desk, string desk, return. Ordinary define own property S, p. Desk 0, 4, 3, 3. The internal method of a string exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let keys be a new empty list. Let str be O, assert. Str is a string. Let len be the length of str for each integer I such that 0I, len, in ascending order, do a append to string I to keys for each own property key p of O such that p is an array index and to an integer or infinity p, len, in ascending numeric index order, do a append p to keys for each own property key p of O such that p is a string and p is not an array index. In ascending chronological order of property creation, do a append p to keys. 90. ECMA International 2024. 8. For each own property key p of O such that p is a symbol. In ascending chronological order of property creation, do a append p to keys. 9. Return keys 0, 4, 3, 4 string create. Value, prototype. The abstract operation string create takes arguments value, a string, and prototype, an object, and returns a string exotic object. It is used to specify the creation of new string exotic objects. It performs the following steps when called. Let S be make basic object. Set S to prototype. Set S to value. Set S as specified in 1, 0, 4, 3, 1.
as long as there isn't a core dump. It's probably working.
copyright sign, ECMA International 2024 277, 13.11 Equality operators, syntax, equality expression, in, yield, await, relational expression in yield await, equality expression in yield await, equals relational expression in yield await, equality expression in yield await equals relational expression in yield await, equality expression in yield await, equals relational expression in yield await, equality expression in yield await equals relational expression in yield await. 3. 1 1 1 runtime semantics, evaluation, equality expression equals relational expression, letter FB. Evaluation of equality expression, letter val B. Get value, ref, letter FB. Evaluation of relational expression, letter val B. Get value, ref, return, is loosely equal, val, equality expression equals relational expression, letter FB. Evaluation of equality expression, letter val B. Get value, ref, letter FB. Evaluation of relational expression, letter val B. Get value, ref, letter B. Is loosely equal, val. If R is true, return false. Otherwise, return true. Equality expression equals relational expression, letter FB. Evaluation of equality expression, letter val B. Get value, ref, letter FB. Evaluation of relational expression, letter val B. Get value, ref, return is strictly equal, val. Equality expression equals relational expression, letter FB. Evaluation of equality expression, letter val B. Get value, ref, letter FB. Evaluation of relational expression, letter val B. Get value, ref, let R be is strictly equal, val. If R is true, return false. Otherwise, return true. 278. ECMA International 2024. Note the result of evaluating an equality operator is always of type Boolean, reflecting whether the relationship named by the operator holds between its two operands. Note 1. Given the above definition of equality, string comparison can be forced by $the equals $b. Numeric comparison can be forced by plus equals plus b. Boolean comparison can be forced by equals b. Note 2. The equality operators maintain the following invariants. Up equals b is equivalent to up equals b. Up equals b is equivalent to b equals a, except in the order of evaluation of a and b. Note 3. The equality operator is not always transitive. For example, there might be two distinct string objects, each representing the same string value. Each string object would be considered equal to the string value by the equals operator, but the two string objects would not be equal to each other. For example, new string equals a and a equals new string are both true. New string equals new string is false. Note 4. Comparison of strings uses a simple equality test on sequences of code unit values. There is no attempt to use the more complex, semantically oriented definitions of character or string equality and collating order defined in the Unicode specification. Therefore, strings values that are canonically equal according to the Unicode standard get test as unequal. In effect, this algorithm assumes that both strings are already in normalized form. 3.12 Binary bitwise operators syntax, bitwise and expression, in, yield, await, equality expression in yield await, bitwise and expression in yield await, and equality expression in yield await, bitwise or expression, in, yield, await, bitwise and expression in yield await, bitwise or expression in yield await, bitwise and expression in yield await, bitwise or expression, in, yield, await, bitwise or expression in yield await, bitwise or expression in yield await, bitwise or expression in yield await. 3. 1 2 1 runtime semantics, evaluation, bitwise and expression and equality expression, return, capital E, V, A, L, U, A, T, E, capital S, T, R I N G capital O R capital N U M E R I C capital B I N A R Y capital E bitwise and expression and equality expression ECMA International 2024 279 bitwise or expression bitwise or expression bitwise and expression return capital E V A L U A T E capital S T R I N G capital O R capital N U M E R I C capital B I N A R Y capital E bitwise or expression bitwise and expression bitwise or expression bitwise or expression bitwise or expression return capital E V A L U A T E capital S T R I N G capital O R capital N U M E R I C capital B I N A R Y capital E bitwise or expression bitwise or expression 3.13 binary logical operators syntax logical and expression in yield await bitwise or expression in yield await logical and expression in yield await and bitwise or expression in yield await logical or expression in yield await logical and expression in yield await logical or expression in yield await logical and expression in yield await coalesce expression in yield await coalesce expression head in yield await bitwise or expression in yield await coalesce expression head in yield await coalesce expression in yield await bitwise or expression in yield await short circuit expression in yield await logical or expression in yield await coalesce expression in yield await 3.13 1 runtime semantics evaluation logical and expression and bitwise or expression letter fb evaluation of logical and expression letter val b get value ref let
It finally ran without crashing.
return val letter fb evaluation of bitwise or expression return ref logical or expression logical and expression letter fb evaluation of logical or expression letter val b get value ref let bool be to boolean val if bool is true return val letter fb evaluation of logical and expression return get value
All I gotta do is figure out if these like relate to the triangle or the quad,
produced by and
and then attach the rest of the stuff.
the value produced note will always be the value of one of the expression coalesce expression head
This is so boring. Get some water.
expression head letter val b get value ref if the val is either undefined or null then a letter of b evaluation of bitwise or expression be return get value ref else a returnal val 3.14 conditional operator syntax conditional expression in yield await short circuit expression in yield await short circuit expression in yield await assignment expression plus in yield await assignment expression in yield await 3.14 1 runtime semantics evaluation conditional expression short circuit expression assignment expression letter fb evaluation of short circuit expression letter val b to boolean get value ref if val is true then a let true ref b evaluation of the first assignment expression be return get value true ref else a let false ref b evaluation of the second assignment expression be return get value false ref Note the grammar for a conditional expression in ECMA script is slightly different from that in C and Java, which each allow the second sub-expression to be an expression but restrict the third expression to be a conditional expression. The motivation for this difference in ECMA script is to allow an assignment expression to be governed by either arm of a conditional and to eliminate the confusing and fairly useless case of a comma expression as the center expression. ECMA International 2024 281 13.15 Assignment operators syntax. Assignment expression in yield await. Conditional expression in yield await plus yield. Yield expression in await. Arrow function in yield await. Async arrow function in yield await. Left-hand side expression yield await equals assignment expression in yield await. Left-hand side expression yield await. Assignment operator assignment expression in yield await. Left-hand side expression yield await. And equals assignment expression in yield await. Left-hand side expression yield await equals assignment expression in yield await. Left-hand side expression yield await equals assignment expression in yield await. Assignment operator 1 of equals percent equals plus equals 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 and equals 3 1 5 1 static semantics. Early errors. Assignment expression left-hand side expression equals assignment expression. If left-hand side expression is either an object literal or an array literal, the following early error rules are applied. Left-hand side expression must cover an assignment pattern. If left-hand side expression is neither an object literal nor an array literal, the following early error rule is applied. It is a syntax error if assignment target type of left-hand side expression is not simple. Assignment expression left-hand side expression assignment operator assignment expression left-hand side expression and equals assignment expression left-hand side expression equals assignment expression left-hand side expressi on equals assignment expression. It is a syntax error if assignment target type of left-hand side expression is not simple. 3 1 5 2 runtime semantics. Evaluation assignment expression left-hand side expression equals assignment expression. 82. If left-hand side expression is neither an object literal nor an array literal, then a letter of B. Evaluation of left-hand side expression. BF is anonymous function definition, assignment expression, and is identifier ref of left-hand side expression are both true. Then I let eval B. Named evaluation of assignment expression with argument ref. C else I let ref B. Evaluation of assignment expression 2. Let eval B. Get value ref D perform. Put value ref reval return reval. Let assignment pattern be the assignment pattern that is covered by left-hand side expression. ECMA International 2024 3. Let ref B. Evaluation of assignment expression. Let eval B. Get value ref perform. Capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V A L U A T of assignment pattern with argument reval. Return reval. Assignment expression left-hand side expression assignment operator assignment expression. Let ref B. Evaluation of left-hand side expression. Let eval B. Get value ref. Let ref B. Evaluation of assignment expression. Let eval B. Get value ref. Let assignment optext be the source text matched by assignment operator. Let optext be the sequence of Unicode code points associated with assignment optext in the following table. Assignment optext equals percent plus equals and equals. Let RB capital A P P L Y capital S T R I N G capital O R capital N U M E R I C capital B I N A R Y, capital O, P, E, R, val, alt text, val, perform, put value, ref, R, return R, assignment expression, left-hand side expression and equals assignment expression, letter of B. Evaluation of left-hand side expression, little val B. Get value, ref, let bool be to boolean, val, if bool is false, return val, if is anonymous function definition, assignment expression, is true and is identifier ref of left-hand side expression is true, then a letter val B. Named evaluation of assignment expression with argument ref, else a letter of B. Evaluation of assignment expression B letter val B. Get value, ref, perform. Put value, ref, reval, return reval, assignment expression, left-hand side expression equals assignment expression, letter of B. Evaluation of left-hand side expression, little val B. Get value, ref, let bool be to boolean, val, if bool is true, return val, if is anonymous function definition, assignment expression, is true and is identifier ref of left-hand side expression is true, then a letter val B. Named evaluation of assignment expression with argument ref 6. Else a letter of B. Evaluation of assignment expression B letter val B. Get value, ref, ECMA International 2024 283 7. Perform. Put value, ref, reval, return reval, assignment expressio, n, left-hand side expression equals assignment expression, letter of B. Evaluation of left-hand side expression, little val B. Get value, ref, if a val is neither undefined nor null, return val, if is anonymous function definition, assignment expression, is true and is identifier ref of left-hand side expression is true, then a letter val B. Named evaluation of assignment expression with argument ref, else a letter of B. Evaluation of assignment expression B letter val B. Get value, ref, perform. Put value, ref, reval, return reval, 3, 1, 5, 3, capital A, P, P, L, Y, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital O, P, E, R, val, alt text, reval. The abstract operation, capital A, P, P, L, Y, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital O, P, E, R, takes arguments val, any CMA script language value, alt text, comma percent, plus, and, or, and reval, any CMA script language value, and returns either a normal completion containing either a string, a begint, or a number, or a throw completion. It performs the following steps when called.
If I can focus for just long enough to track down the last couple pointers, put them in place,
Reprim is a string.
get the last couple calls in place,
To string.
and get it done. I'll be done. Be done with this.
3.
I gotta focus.
R and RS.
Oh, this is so annoying.
Altel prim. Set reval to reprim. Note. At this point, it must be a numeric operation. Letter num B. To numeric. Val. Letter num B. To numeric. Reval. If type. Num. Is not type. Renum. Throw a type error exception. If num is a big int, then, note when this expression occurs within strict mode code. It is a runtime error if ref in step 1D. 2. 2. 2. 2 is an unresolvable reference. If it is, a reference error exception is thrown. Additionally, it is a runtime error if the ref in step 8, 7, 7, 6 is a reference to a data property with the attribute value false, to an accessor property with the attribute value ABCD. Let if optext is return big int exponentiate num renum. If optext is comma return big int divide num renum. If optext is percent return big int remainder num renum. If optext is return big int unsigned right shift num renum. Operation be the abstract operation associated with optext and type num. In the following table, 84 ECMA International 2024 optext type num. Operation number exponentiate number multiply big int multiply number divide number remainder number add percent plus number number big int number number number. Optext type num plus big int number big int number big int number big int comma number number big int number big int number big int. Operation big int add number subtract big int subtract number left shift big int left shift number signed right shift big int signature right shift number and signed right shift number bitwise and big int bitwise and number bitwise or big int bitwise or number bitwise or big int bitwise or return operation num renum. Note 1 no hint is provided in the calls to primitive in steps 1a and 1b. All standard objects except dates handle the absence of a hint as if number were given. Dates handle the absence of a hint as if string were given. Exotic objects may handle the absence of a hint in some other manner. Note 2 step 1c differs from step 3 of the is less than algorithm by using the logical or operation instead of the logical and operation. 3 1 5 4 capital E V A L U A T E capital S T R I N G capital O R capital N U M E R I C capital B I N A R Y capital E left operand optext right operand. The abstract operation capital E V A L U A T E capital S T R I N G capital O R capital N U M E R I C capital B I N A R Y capital E takes arguments left operand a parse node optext a sequence of Unicode code points and right operand a parse node and returns either a normal completion containing either a string a big int or a number or an abrupt completion. It performs the following steps when called. Letter FB evaluation of left operand letter val B get value ref letter FB evaluation of right operand letter val B get value ref return capital A P P L Y capital S T R I N G capital O R capital N U M E R I C capital B I N A R Y capital O P E R val optext reval 3 1 5 destructuring assignment supplemental syntax. In certain circumstances when processing an instance of the production assignment expression, left-hand side expression equals assignment expression. The interpretation of left-hand side expression is refined using the following grammar. Assignment pattern, yield, await, object assignment pattern yield await, array assignment pattern yield await. ECMA International 2024 285. Object assignment pattern yield await. Assignment dress property yield await. Assignment property list yield await. Assignment property list yield await. Assignment dress property yield await opt. Array assignment pattern yield await. Elisionort assignment rest element yield await opt. Assignment element list yield await. Assignment element list yield await. Elisionort assignment rest element yield await opt. Assignment rest property yield await dart. Destructuring assignment target yield await. Assignment property list yield await. Assignment property yield await. Assignment property list yield await. Assignment property yield await. Assignment element list yield await. Assignment elision element yield await. Assignment element list yield await. Assignment elision element yield await. Assignment elision element yield await. Elisionort assignment element yield await. Assignment property yield await. Identifier reference yield await. Initializer plus in yield await opt. Property name yield await. Assignment element yield await. Assignment element yield await. Destructuring assignment target yield await. Initializer plus in yield await opt. Assignment rest element yield await dart. Structuring assignment target yield await. Destructuring assignment target yield await. Left hand side expression yield await. 3 1 5 5 1 static semantics. Early errors. Assignment property identifier reference initializer opt. It is a syntax error if assignment target type of identifier reference is not simple. Assignment rest property destructuring assignment target. It is a syntax error if destructuring assignment target is either an array literal or an object literal. Destructuring assignment target left-hand side expression. If left-hand side expression is either an object literal or an array literal, the following early error rules are applied. Left-hand side expression must cover an assignment pattern. If left-hand side expression is neither an object literal nor an array literal, the following early error rule is applied. 86. Copyright sign, ECMA International 2024. It is a syntax error if assignment target type of left-hand side expression is not simple. 1 3 1 5 5 to runtime semantics. Capital D E S T R U C T U R I N G. Capital A S S I G N M E N T. Capital E V A L U A T. The syntax directed operation. Capital D E S T R U C T U R I N G. Capital A S S I G N M E N T. Capital E V A L U A T. Takes argument value, any CMA script language value, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Object assignment pattern. Perform. Require object coercible. Value. Return unused. Object assignment pattern. Assignment property list. Assignment property list. Perform. Require object coercible. Value. Perform. Capital P R O P E R T Y. Capital D E S T R U C T U R I N G. Capital A S S I G N M E N. Of assignment property list with argument value. Return unused. Object assignment pattern. Assignment rest property. Perform. Require object coercible. Value. Let excluded names be a new empty list. Return. Capital R E S T. Capital D E S T R U C T U R I N G. Capital A S S I G N M E N T. Capital E V A. Of assignment rest property with arguments value and excluded names. Object assignment pattern. Assignment property list. Assignment dress property. Perform. Require object coercible. Value. Let excluded names be. Capital P R O P E R T Y. Capital D E S T R U C T U R I N G. Capital A S S I G N M E N. Of assignment property list with argument value. Return. Capital R E S T. Capital D E S T R U C T U R I N G. Capital A S S I G N M E N T. Capital E V A. Of assignment dress property with arguments value and excluded names. Array assignment pattern. Let iterator record B. Get iterator value. Sync. Return. Iterator close. Iterator record. Normal completion. Unused. Array assignment pattern. Elision. Let iterator record B. Get iterator value. Sync. Let result be completion. Iterator destructuring assignment evaluation of elision with argument. Iterator record. If iterator record is false, return. Iterator close. Iterator record. Result. Return result. Array assignment pattern. Elision launch assignment dressed element. Let iterator record B. Get iterator value. Sync. If elision is present, then a let status be completion. Iterator destructuring assignment evaluation of elision with argument iterator record. B if status is an abrupt completion, then I assert iterator record is true. 2. Return status. Let result be completion. Iterator destructuring assignment evaluation of assignment dressed element with argument iterator record. ECMA International 2024 287. 4. If iterator record is false, return. Iterator close. Iterator record. Result. Return result. Array assignment pattern. Assignment element list. Let iterator record B. Get iterator value. Sync. Let result be completion. Iterator destructuring assignment evaluation of assignment element list with argument iterator record. If iterator record is false, return. Iterator close. Iterator record. Result. Return result. Array assignment pattern. Assignment element list. Elision launch assignment dressed element opt. Let iterator record B. Get iterator value. Sync. Let status be completion. Iterator destructuring assignment evaluation of assignment element list with argument iterator record. If status is an abrupt completion, then if iterator record is false, return. Iterator close. Iterator record. Status. B return status. If elision is present, then assert status to completion. Iterator destructuring assignment evaluation of elision with argument iterator record. B if status is an abrupt completion, then I assert iterator record is true. 2. Return status. If assignment dressed element is present, then assert status to completion. Iterator destructuring assignment evaluation of assignment dressed element with argument iterator record. If iterator record is false, return. Iterator close. Iterator record. Status. Return status. 3. 1 5 5 3 runtime semantics. Capital P R O P E R T Y. Capital D E S T R U C T U R I N G. Capital A S S I G N M E N. The syntax directed operation. Capital P R O P E R T Y. Capital D E S T R U C T U R I N G. Capital A S S I G N M E N. Takes argument value. any CMA script language value, and returns either a normal completion containing a list of property keys or an abrupt completion. It collects a list of all the structured property keys. It is defined piecewise over the following productions: assignment property list, assignment property list, assignment property. Let property names be capital P R O P E R T Y, capital D E S T R U C T U R I N G, capital A S S I G N M E N, of assignment property list with argument value. Let next names be capital P R O P E R T Y, capital D E S T R U C T U R I N G, capital A S S I G N M E N, of assignment property with argument value. Return the list concatenation of property names and next names. Assignment property identifier reference initializer opt. Let P be string value of identifier reference. Let ref be resolve binding. P let V be jet value P if initializer is present and V is undefined. Then if is anonymous function definition initializer is true, then I set v2. Named evaluation of initializer with argument P be else I let default value be evaluation of initializer 2. Set v2. Get value default value perform. Put value ref V return P 88. ECMA International 2024. Assignment property pro perty name assignment element. Let name be evaluation of property name perform. Capital K E Y E D, capital D E S T R U C T U R I N G, capital A S S I G N M E N T, capital E V, of assignment element with arguments value and name. Return name 315 5 for runtime semantics. Capital R E S T, capital D E S T R U C T U R I N G, capital A S S I G N M E N T, capital E V A. The syntax directed operation. Capital R E S T, capital D E S T R U C T U R I N G, capital A S S I G N M E N T, capital E V A, takes arguments value, any CMA script language value, and excluded names, a list of property keys, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions: assignment dress property, destructuring assignment target. Let ref be evaluation of destructuring assignment target. Let rest obj be ordinary object create %object prototype %perform. Copy data properties. Rest obj value excluded names. Return. Put value ref rest obj 315 5 runtime semantics. Capital I T E R A T O R, capital D E S T R U C T U R I N G, capital A S S I G N M E N. The syntax directed operation. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, takes argument iterator record, an iterator record, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions: assignment element list, assignment elision element, return, capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of assignment elision element with argument iterator record, assignment element list, assignment element list, assignment elision element, perform, capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of assignment element list with argument iterator record, return, capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of assignment elision element with argument iterator record, assignment elision element, assignment element, return, capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of assignment element with argument iterator record, assignment elision element, elision assignment element, perform, capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of elision with argument iterator record, return, capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of assignment element with argument iterator record, elision. If iterator record is false, then a let next be completion, iterator step, iterator record, B if next is an abrupt completion, set iterator record to true, C return if abrupt, next, D if next is false, set iterator record to true, return unused, elision, elision, perform, capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of elision with argument iterator record. If iterator record is false, then a let next be completion, iterator step, iterator record, B if next is an abrupt completion, Set iterator record to true. ECMA International 2024 289. See return if abrupt. Next. D if next is false. Set iterator record to true 3. Return unused. Assignment element. Destructuring assignment target initial is eropt. If destructuring assignment target is neither an object literal nor an array literal, then elect if b. Evaluation of destructuring a segment target. Let value be undefined. If iterator record is false, then elect next b. Iterator step value. Iterator record b. If next is not done, then I set value to next. If initializer is present and value is undefined, then if is anonymous function definition. Initializer is true and is identifier ref of destructuring assignment target is true, then I let VB. Named evaluation of initializer with argument ref b else I let default value b. Evaluation of initializer 2. Let VB. Get value. Default value else I let VB value. If destructuring assignment target is either an object literal or an array literal, then a let nested assignment pattern be the assignment pattern that is covered by destructuring assignment target. Be return capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V A L U A T of nested assignment pattern with argument V. Return. Put value ref V assignment rest element. Destructuring assignment target. If destructuring assignment target is neither an object literal nor an array literal, then elect ref B. Evaluation of destructuring assignment target. Let A be array create 0. Let 0 repeat. While iterator record is false, elect next b. Iterator step value. Iterator record b. If next is not done, then I perform create data property or throw a to string n next 2. Set n to n plus 1. If destructuring assignment target is neither an object literal nor an array literal, then a return. Put value ref a. Let nested assignment pattern be the assignment pattern that is covered by destructuring assignment target. Return capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V A L U A T of nested assignment pattern with argument A 3 1 5 5 6 runtime semantics capital K E Y E D capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V. The syntax directed operation capital K E Y E D capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V takes arguments value, any CMA script language value, and property name, a property key, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Assignment element. Destructuring assignment target initial is eropt. If destructuring assignment target is neither an object literal nor an array literal, then elect ref B. Evaluation of destructuring assignment target. Let VB. Jet. Value. Property name. If initializer is present and V is undefined, then 290. ECMA International 2024. Note left to right evaluation order is maintained by evaluating a destructuring assignment target that is not a destructuring pattern prior to accessing the iterator or evaluating the initializer. If is anonymous function definition, initializer, and is identifier ref of destructuring assignment target to both true. Then, I let RHS value be. Named evaluation of initializer with argument ref be else. I let default value be. Evaluation of initializer 2. Let RHS value be. Get value. Default value else. A let RHS value be v. If destruct Turing assignment target is either an object literal or an array literal, then a let assignment pattern be the assignment pattern that is covered by destructuring assignment target be return. Capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V A L U A T of assignment pattern with argument RHS value return. Put value ref RHS value 3.16 comma operator syntax expression in yield await assignment expression in yield await expression in yield await assignment expression in yield await 1316 1 runtime semantics evaluation expression assignment expression let ref be evaluation of expression perform get value ref let ref be evaluation of assignment expression return get value ref for ECMA script language statements and declarations syntax statement yield await return block statement yield await return variable statement yield await empty statement expression statement yield await if statement yield await return breakable statement yield await return continue statement yield await break statement yield await plus return statement yield await with statement yield await return labeled statement yield await return throw statement yield await try statement yield await return debugger statement note get value must be called even though its value is not used because it may have observable side effects. ECMA International 2024 291 declaration yield await hoistable declaration yield await default class declaration yield await default lexical declaration plus in yield await hoistable declaration yield await default function declaration yield await default generator declaration yield await default async function declaration yield await default async generator declaration yield await default breakable statement yield await return iteration statement yield await return switch statement yield await return 4.1 statement semantics 4.1 runtime semantics evaluation hoistable declaration generator declaration async function declaration async generator declaration return empty hoistable declaration function declaration return evaluation of function declaration breakable statement iteration statement switch statement let new label set be a new empty list return labeled evaluation of this breakable statement with argument new label set 4.2 block syntax block statement yield await return block yield await return block yield await return statement list yield await return opt statement list yield await return statement list item yield await return statement list yield await return statement list item yield await return statement list item yield await return statement yield await return declaration yield await 92 ECMA International 2024 142 1 static semantics early errors block statement list it is a syntax error if the lexically declared names of statement list contains any duplicate entries. It is a syntax error if any element of the lexically declared names of statement list also occurs in the are declared names of statement list 4.2 runtime semantics Evaluation block. Return empty block. Statement list. Let old env be the running execution context's lexical environment. Let block env be new declarative environment. Old env perform block declaration instantiation. Statement list. Block env. Set the running execution context's lexical environment to block env. Let block value be completion. Evaluation of statement list. Set the running execution context's lexical environment to old env. Return block value. Statement list. Statement list item. Let SL be. Evaluation of statement list. Let S be completion. Evaluation of statement list item. Return. Update empty. S. SL. 4. 2. 3 block declaration instantiation. Code. env. The abstract operation block declaration instantiation takes arguments code, a parse node, and env, a declarative environment record, and returns unused code is the parse node corresponding to the body of the block. Env is the environment record in which bindings are to be created. It performs the following steps when called. Let declarations be the lexically scoped declarations of code. Let private env be the running execution context's private environment. For each element D of declarations, do a for each element dn of the bound names of D. Do ECMA International 2024-293. Note 1. No matter how control leaves the block, the lexical environment is always restored to its former state. Note 2. The value of a statement list is the value of the last value producing item in the statement list. For example, the following calls to the eval function all return the value 1 eval 1 eval 1 eval 1 var a. Note when a block or case block is evaluated, a new declarative environment record is created and bindings for each block scoped variable, constant, function, or class declared in the block are instantiated in the environment record. If this constant declaration of D is true, then perform env create a mutable binding. dn true 2. Else perform env create mutable binding. dn false. Note, the step is replaced in section B 3 2 6. B if D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration, then I let fn be the sole element of the bound names of D. 2. Let fo be instantiate function object of D with arguments env and private env. 3. Perform env initialize binding fn fo. Note, the step is replaced in section B 3 2 6. Return unused 4.3 declarations in the variable statement. 4 3 1. Syntax. Lexical declaration in yield await. Let or const binding list in yield await. Let or const binding list in yield await. Lexical binding in yield await. Binding list in yield await. Lexical binding in yield await. Lexical binding in yield await. Binding identifier yield await. Initializer in yield await. Opt binding pattern yield await. Initializer in yield await. 4 3 1 1. Static semantics. Early errors. Lexical declaration. Let or const binding list. It is a syntax error if the bound names of binding list contains let. It is a syntax error if the bound names of binding list contains any duplicate entries. Lexical binding. Binding identifier initializer opt. It is a syntax error if initializer is not present and is constant declaration of the lexical declaration containing this lexical binding is true. 94. ECMA International 2024. Let and const declarations. Let and const declarations define variables that are scoped to the running execution contexts. Note, lexical environment. The variables are created when their containing environment record is instantiated but may not be accessed in any way until the variable's lexical binding is evaluated. A variable defined by a lexical binding with an initializer is assigned the value of its initializer's assignment expression when the lexical binding is evaluated, not when the variable is created. If a lexical binding in a let declaration does not have an initializer, the variable is assigned the value undefined when the lexical binding is evaluated. 1 4 3 1. 2. Runtime semantics. Evaluation. Lexical declaration. Let or const binding list. Perform. Evaluation of binding list. Return empty. Binding list. Binding list. Lexical binding. Perform. Evaluation of binding list. Return. Evaluation of lexical binding. Lexical binding. Binding identifier. Let LHS be. Resolve binding. String value of binding identifier. Perform. Initialize reference binding. LHS. Undefined. Return empty. Lexical binding. Binding identifier initializer. Let binding ID be string value of binding identifier. Let LHS be. Resolve binding. Binding ID. If is anonymous function definition, initializer, is true, then let value be. Named evaluation of initializer with argument binding ID. Else, let RHS be. Evaluation of initializer, be let value be. Get value, RHS. Perform. Initialize reference binding, LHS. Value. Return empty. Lexical binding. Binding pattern initializer. Let RHS be. Evaluation of initializer. Let value be. Get value, RHS. Let env be the running execution context's lexical environment. Return. Binding initialization of binding pattern with arguments value and env. 4, 3, 2 variable statement. Syntax. Variable statement. Yield. Await. Our variable declaration list. Plus in yield await. A static semantics rule ensures that this form of lexical binding never occurs in a const. Note. Declaration. A var statement declares variables that are scoped to the running execution contexts. Note. Variable environment. Our variables are created when they're containing environment record is instantiated and are initialized to undefined when created. Within the scope of any variable environment, a common binding identifier may appear in more than one variable declaration, but those declarations collectively define only one variable. A variable defined by a variable declaration with an initializer is assigned the value of its initializer's assignment expression when the variable declaration is executed, not when the variable is created. ECMA International 2024-295. Variable declaration list. In yield await. Variable declaration in yield await. Variable declaration list in yield await. Variable declaration in yield await. Variable declaration in yield await. Binding identifier yield await. Initializer in yield await opt. Binding pattern yield await. Initializer in yield await. 4, 3, 2, 1 runtime semantics. Evaluation. Variable statement. var variable declaration list. Perform. Evaluation of variable declaration list. Return empty. Variable declaration list. Variable declaration list. Variable declaration. Perform. Evaluation of variable declaration list. Return. Evaluation of variable declaration. Variable declaration. Binding identifier 1. Return empty. Variable declaration. Binding identifier initializer. Let binding ID be string value of binding identifier. Let LHS be. Resolve binding. Binding ID. If is anonymous function definition, initializer, is true, then a let value be. Named evaluation of initializer with argument binding ID. Else a let RHS be. Evaluation of initializer be let value be. Get value RHS. Perform. Put value LHS. Value. Return empty. Variable declaration. Binding pattern initializer. Let RHS be. Evaluation of initializer. Let val be. Get value RHS. Return. Binding initialization of binding pattern with arguments reval and undefined. 4, 3, 3 destructuring binding pattern syntax. Binding pattern. Yield. Await. Object binding pattern yield await. Array binding pattern yield await. Note if a variable declaration is nested within a with statement and the binding identifier in the variable declaration is the same as the property name of the binding object of the with statement's object environment record. Then step 5 will assign value to the property instead of assigning to the variable environment binding of the identifier. 96. ECMA International 2024. Object binding pattern. Yield. Await. Binding rest property yield await. Binding property list yield await. Binding property list yield await. Binding rest property yield await opt. Array binding pattern. Yield. await. Elisionort binding rest element yield await opt. Binding element list yield await. Binding element list yield await. Elisionort binding rest element yield await opt. Binding rest property yield await dart. Binding identifier yield await. Binding property list yield await. Binding property yield await. Binding property list yield await. Binding property yield await. Binding element list yield await. Binding elision element yield await. Binding element list yield await. Binding elision element yield await. Binding elision element yield await. Elisionort binding element yield await. Binding property yield await. Single name binding yield await. Property name yield await. Binding element yield await. Binding element yield await. Single name binding yield await. Binding pattern yield await. Initializer plus in yield await opt. Single name binding yield await. Binding identifier yield await. Initializer plus in yield await opt. Binding rest element yield await dart. Binding identifier yield await. Binding pattern yield await. 4, 3, 3, 1 runtime semantics. Property binding initialization. The syntax directed operation property binding initialization takes arguments value, any CMA script language value, and
Okay, so basically,
return
chatbot is like a loop from hell.
list of property keys or an abrupt completion. It collects a list of all bound defined piecewise over the
Chatbot said it dropped in blah blah, and it's like, let me know when you're ready for the next edition.
names B.
Find memory type, SCP image.
Property list with argument.
This is already done.
Let next names B. Property
That's covered with this.
property with arguments.
The thing that I added, whatever.
Turn the list concatenation of bound names and next names. ECMA International 2020.
Right here.
Binding property. Single name binding. Let name be the sole element.
So if I told chatbot yes
Keep binding in
after these steps,
with arguments value, environment, and name. Return.
I would have been on in a circle again, with never-ending chatbot always saying, "Oh, here's what you need. Here's what you need." So like,
Arguments value.
I think I hit the end of chatbot, then a loop. I broke the cycle.
Runtime.
I finally reached the end of chatbot.
The syntax directed
So tomorrow,
arguments value. And
I can't take this anymore.
value. Environment and environment record or undefined.
It's actually throwing an error that's not like a fatal error. It just means that something's not configured totally right.
Over the following production.
So I need to rip out all the dead code
LHSB.
tomorrow.
String value of
Find out exactly what's being used.
OBJB ordinary object create. Object prototype.
Because I'm not totally sure.
Data properties. Rest.
I have
Excluded names. If environment is undefined. Return. Put value. LHS. Rest OBJ.
whatever the heck the
Reference binding.
descriptor pool and shit.
4, 3, 3, 3 run.
I just like half-assed connected things, get it running.
Syntax directed operation keep binding initialization takes arguments value. Any CMA script language value. Environment.
So like this triangle,
Record or undefined. And property name. A property key. And returns either a normal completion.
and the quad.
Abrupt completion. It is defined piecewise over the following productions. Binding element. Binding pattern.
They both run off the same exact code.
Jet.
Like the same exact code. I bit my tongue. I can't talk.
Present and V is undefined. Then a let default value.
Use the same exact code. Except
V2. Get value. Default value. Return. Binding initialization of binding pattern with arguments V and environment.
the quad
Binding identifier initializer opt. Let
has 6 vertices
identifier. Let LHSB.
instead of 4.
Binding IT. Environment. Let VB. Jet. Value. Property name. If initializer is
Or 3.
defined.
So here's the triangle. And here's the quad.
Is true. Then I set V2. Named evaluation of initializer with argument binding id. Be else. Note when undefined is passed for environment, it indicates that a put value.
So like split it up, but they're basically the same thing.
Value. This is the case for formal.
Let me copy this and we'll gotta find it tomorrow.
In that case, the formal parameter bindings are pre-initialized in order to deal with the possibility of multiple parameters with the same name. 98. ECMA International 2024. I2. Let default value be. Evaluation of initializer.
So the command buffers and stuff,
Value.
and the pipeline layout, they're all tied to the triangle or the quad.
Value. LHS. V. Return. Initialize reference binding.
But then there's also, so like they're both like separate, luckily. But I gotta like
4. 1.
figure out what's the difference between that and
Statement.
the desktop capture.
Return empty. 4.5 expression statement syntax. Expression statement. Yield. Await. Look ahead. Function. Async.
Because this goes to a 2D plane
Class.
and it uses a
Class in yield await. Note an expression.
texture image or something, I don't even know. It uses the same exact freaking properties or parameters or whatever you want to call them as the shader,
Ambiguous.
except with the 2D plane it just blitzes it, so it's like a simple setup.
Expression statement.
With the shader there's like a whole bunch of extra steps,
Sync generate a declaration.
so I have to figure out how to like
Statement cannot start with the 2 token sequence. Let
turn this off or whatever,
lexical
like disable it completely to make sure I'm not accidentally attaching to this,
one runtime
and then I'm only attaching to the triangle, because like
simulation. Let x per f be.
when I turn this one on I like fuck up the triangle.
The ref 4 points.
If I turn off the video
If state
it like the triangle flickers and stuff,
return if express
so like somewhere I'm like, I don't know,
statement yield await return.
I'm like overriding the quad with the 2D or something, I don't even know.
Wait. State
So I gotta sort that out tomorrow,
look ahead else. The look at
and I think they'll actually finally have
S solves the classic dangling else problem in there. Note you
the image or whatever on the quad.
if is otherwise
I think this is the end of it,
associated with the nearest.
because now when it throws an error message,
ECMA International
so it still works whatever the quad works.
29 146 1 static semantics early errors if statement
And it, I don't know, whatever. So it works, right?
is a syntax error if is labeled function.
So I turn this code to like
Syntax error if is labeled function.
bind the image to it,
Statement
but a step in here is missing, and I think it's attached to the 2D plane of the desktop capture.
to apply this rule if the extension specified in B.
So it's attached not to the quad, but like both the quad and the desktop capture.
If statement
I bit my tongue. I cannot talk.
else statement let x per
I'm talking weird.
expression let x per value be to boolean.
So since it's like attached to both,
If x per value
I don't know what's going on. At least it's an error message. It doesn't say like core dumped. It says error.
let s
It actually prints an error message.
evaluation
So now when I run it, the quad doesn't spin, but I get the error message.
completion undefined. If statement if expression statement let x per f be. Evaluation of expression
So tomorrow,
get value
I just have to clean up the code.
is false. Then a return
I hope my tongue freaking heals because I cannot talk
completion
without sounding weird.
be return update
I can't say tongue. Anyways,
m.7 iterate
hopefully my tongue heals. All I gotta do though is like clean up the fucking code.
yield
I gotta remove the 2D plane with the desktop capture
statement yield
to make sure I'm not accidentally attaching between that and the other one, whatever.
then 1 semantics
And I'd like separate the quad from that. I don't know. And then I think it's done.
operation loop continue.
And then this is like the end of it. Chatbot says like more shit. This is all I need though. This is it.
Runs a boolean. It performs the
tomorrow, I have to be done. I'm so close to being done now.
Completion.
I lost a whole day working on freaking
ECMA International 2.
converting chatbots, broke ass code. For frick's sake.
Return false. 4, 7.
But this looks like it works, so
Loop evaluate.
I don't know. I'm done for now.
Operation
It's getting so old.
makes argument label set, a list of strings, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise at
But then
iteration state
the
while statement return
quad,
loop evaluation of do while statement with argument label
I think you get it in the vertex layer.
return while loop evaluation of while statement with argument label set iteration
I don't know. All I know is that
return
it binds, so it probably goes in here.
label set iterations
All I gotta do is figure out how to like bind it to like
loop eval
location 0 and give it the fucking name.
4, 7, 2
And I can access it through whatever the fuck it does, and then it'll show up on the quad. That's all that's left.
while
After I fix that error.
plus and yield await 4, 7, 2 1 static semantics early errors do while state
So I don't know. I think I'm almost done.
expression it function statement is
So I'm gonna let the stream go on for like 10 more minutes, and then so it sends the whole stream, because it doesn't always send the whole stream. I can't talk. My tongue's killing me. I don't know, peace.
evaluation the syntax directed operation do while loop evaluation
The quad, it's gotta be done tomorrow.
strings and returns either an
Or not. I really hope I can get it done. It's taking way too long. My tongue is killing me.
find piecewise over the following productions do while statement do statement while expression let v be undefined 2 repeat a let stmt result be completion evaluation of statement b if loop continues stmt result label set is false return update empty stmt result v see if stmt result is not empty set v to stmt result d let x per f be evaluation of expression note within the statement part of an iteration statement a continue statement may be used to begin a new iteration copyright sign ECMA International 2024 301 e let x per value b get value x per f if to boolean x per value is false return v 4 7 3 while statement syntax while statement yield await return while expression plus and yield await statement yield await return 4 7 3 1 static semantics early errors while statement while expression statement it is a syntax error if is labeled function statement is true note it is only necessary to apply this rule if the extension specified in b 3.1 is implemented 1 4 7 3 to runtime semantics while loop evaluation the syntax directed operation while loop evaluation takes argument label set a list of strings and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions while statement while expression statement let v be undefined 2 repeat a let x per f be evaluation of expression b let x per value b get value x per f see if to boolean x per value is false return v d let stmt result be completion evaluation of statement e if loop continues stmt result label set is false return update empty stmt result v if stmt result is not empty set v to stmt result 4 7 fourth f for statement syntax for statement yield await return 4 look ahead let expression in yield await opt 1 4 7 4 1 expression plus in yield await opt expression plus in yield await opt statement yield await return 4 var variable declaration list in yield await expression plus in yield await opt expression plus in yield await opt. Statement yield await return. 4. Lexical declaration in yield await. Expression plus in yield await opt. Expression plus in yield question mark await opt. Statement yield await return. Static semantics. Early errors for statement. 4. Express not. Express not. Express not statement. 4. Variable declaration list. Express not. Express not statement. 4. Lexical declaration express not. Express not statement. 02. ECMA International 2024. It is a syntax error if is labeled function. Statement is true. Note it is only necessary to apply this rule if the extension specified in B 3.1 is implemented. For statement 4. Lexical declaration express not. Express not statement. It is a syntax error if any element of the bound names of lexical declaration also occurs in the are declared names of statement. 4. 7. 4. To runtime semantics. For loop evaluation, the syntax-directed operation for loop evaluation takes argument label set, a list of strings, and returns either a normal completion containing an ECMA script language value or an abrupt completion. It is defined piecewise over the following productions. For statement 4. Express not. Express not. Express not statement. If the first expression is present, then let x the ref be. Evaluation of the first expression be perform. Get value x the ref. If the second expression is present, let test be the second expression. Otherwise, let test be empty. If the third expression is present, let increment be the third expression. Otherwise, let increment be empty. Return. For body evaluation, test, increment, statement, label set. For statement 4. Variable declaration list. Express not. Express not statement. Perform. Evaluation of variable declaration list. If the first expression is present, let test be the first expression. Otherwise, let test be empty. If the second expression is present, let increment be the second expression. Otherwise, let increment be empty. Return. For body evaluation, test, increment, statement, label set. For statement 4. Lexical declaration express not. Express not statement. Let oldEnv be the running execution context's lexical environment. Let loopEnv be new declarative environment. oldEnv, let isConst be as constant declaration of lexical declaration. Let bound names be the bound names of lexical declaration. For each element dn of bound names, do. If isConst is true, then I perform loopEnv create immutable binding. dn true be else, I perform loopEnv create mutable binding. dn false, set the running execution context's lexical environment to loopEnv. Let for DCL be completion. Evaluation of lexical declaration. If for DCL is an abrupt completion, then A set the running execution context's lexical environment to oldEnv be return for DCL. If isConst is false, let per iteration lets be bound names. Otherwise